Hi everyone, this is Tango Alpha 2 Sierra Tango Oscar. When radio amateurs want to exchange text messages, they use digital modes. A digital mode usually comes as a software program that runs on a PC. Ham radio is connected to the PC over a USB cable or sometimes with an audio cable. LongChat is a new power-efficient digital mode. It encodes the text messages with chirp symbols, similar to what bats and dolphins do while navigating and communicating. This video will cover a LongChat text message exchange between a transmitter and a receiver. Distance between transmitter and receiver is 2.3 kilometers. Transmitter power output is just 45 microwatts. As illustrated in the picture, an ICOM 7300 transmitter is connected to a laptop that runs LongChat software. ICOM 7300 transmits the text messages encoded by the LongChat software. Transmitter RF output is connected to a rooftop vertical antenna. To receive and decode the text messages, I used a RSP1A receiver. It's connected to a second laptop that runs LongChat software. During testing, receiver and laptop will be at the back seat of the car. Receiver antenna is at the top of the car. Test setup parameters are as follows: 40 bits per second net user data rate, SSP modulation, 50 MHz frequency, 2.4 kHz bandwidth, minus 13 decibel minimum error-free signal-to-noise ratio, and during testing, a text message will be transmitted every 8 seconds. This is the setup of the transmitting side of the system. ICOM 7300 is connected with a USB cable to a PC running the LongChat software. Frequency is at 50 MHz, power output is set to 1%. Now I click the connect button. A block of 17 one-digit numbers will be transmitted every 8 seconds for test purposes. These are the numbers transmitted. At the back side, RF output is connected to RF attenuators with a total value of 46 decibels in series. Output power is measured by a AD8310 power meter in a metal enclosure. A multimeter reads the output voltage corresponding to the measured power. Now let's start the test. Measured voltage is approximately 1.955 during the transmission. Transmit antenna is coming through the chimney, and I have connected it to a nano VNA to measure the standing wave ratio. Standing wave ratio is about 1.18, around 1.2. Transmitting antenna is an omnidirectional quarter wave antenna with 4 ground radials. I use aluminum rods for the verticals and radials. Radials are fixed, but vertical rod is connector detachable in order to use other vertical rods for shorter wavelengths. Receiving antenna is also an omnidirectional quarter wave antenna. I used a thin brass rod for the antenna. A magnet base attaches antenna to the roof. Its standing wave measurement at 50 MHz is about 1.8. I park my car at the receiving location. At the transmitting location is a radio ham friend TA2NBG. During testing, he will gradually reduce the transmitted power by changing the RF attenuators. I try to locate the transmitter antenna location by camera zoom. In the video, I put a red circle around it. Transmitted power is now around 1.8 milliwatt. Modulation is lower sideband. Signal-to-noise ratio fluctuates between plus 1.5 and 1.2. You can still see the received signal at the waterfall display of STR Uno software. Messages are received without any error. Transmitted power is reduced to 45 microwatts. Signal-to-noise ratio fluctuates between minus 13.5 to minus 11.7 decibels. Received signal is no more visible at the waterfall display. Messages are received without any error. Please note that frequency value, bandwidth and modulation type displayed by the LongChat for the RSP1A receiver are actually irrelevant. They are the default values set up by software for non-supported rigs. LongChat currently does not control or receive rig data from RSP1A receiver. Only the audio is transferred to LongChat. All settings are done on the STR Uno software that comes with the RSP1A receiver. Transmitted power is further reduced to around 18 microwatts. Signal-to-noise ratio is around minus 16 to minus 14.6. Errors now started to appear in the received messages. A yellowish background color indicates that error correction codes are no longer able to correct errors in the received messages. Let us now discuss the specifications of LongChat. Its net user data rate is 40 bits per second. This is pure user data rate and does not comprise synchronization bits and error correction codes. Messages use 7-bit ASCII characters, hence 40 bits per second roughly translate to 6 ASCII characters per second. Audio bandwidth of 2.4 kHz is used between 300 Hz to 2700 Hz. While receiving messages, signal-to-noise ratio of minus 13 dB is the lower limit for error-free messaging. However, depending on the type of noise, you may receive messages as low as at 16 dB with some error. This specification, which is the energy per bit to the spectral noise density value, is an indicator of the power efficiency of LongChat. It's calculated by using net data bit rate, signal-to-noise ratio, and bandwidth of the digital mode. This is a good way to compare the power efficiency of various digital modes which have different bit rates, signal-to-noise ratios, and bandwidths. It basically helps us to compare apples and oranges. My next video will be about comparing the power efficiency of LongChat with other digital ham radio modes. My initial judgment is that LongChat is probably the most power efficient digital mode at the moment. Forward error correction codes are used to correct errors up to a certain length. One of the useful features of LongChat is its ability to measure and display the signal-to-noise ratio of the received message. This helps the operator to increase or decrease the transmitter power output accordingly. Measurements of the frequency offset between transmitter and receiver is also a useful feature. Frequency offsets can happen due to shifts in the local crystal oscillators of the devices. Using this value, one or both sides can fine adjust their set frequency to match each other's frequency. This measurement is not the absolute value of the frequency, but the relative difference between receiver and transmitter frequencies. LongChat is computationally intensive for decoding messages on the receiver side, but not so much intensive for encoding on the transmitter side. Constant amplitude envelope of LongChat signals may simplify the QRP transmitter design. Single sideband modulation for LongChat may be directly generated by low-cost programmable oscillators like SI5350 without the need for a special modulator chip. These properties make LongChat attractive for various low-cost, low-power, simplex sensor applications like home and fire alarm sensors, IoT sensors, and etc. LongChat in future may be modified to run on smartphones. A small battery-operated QRP transceiver can pair with a smartphone to function as a personal communicator. My next video will compare the power efficiency of LongChat and other digital modes. A very informative article by Pieter-Tjerk de Boer explained the subject and lists the power efficiency of various digital modes in a table. I put the article link in the YouTube video description. You may download the free LongChat software and setup manual from the link in the YouTube video description. Thank you for watching.